They told us these names were gone forever, but in the digital age, a black bar is just a data point waiting to be decoded. This is a redacted document from the Epstein case, and someone's identity is buried right here. The DOJ wants us to see a dead end, but what truly lies before us is a geometry problem. Using my custom tool Unredact, I'm firing off a multi-phase algorithm that layers OCR and computer vision and AI to analyze the surrounding typography. With a few micro corrections, I'm able to reconstruct the original typeface and text of the document and gain the exact pixel dimensions of the redacted text. With this in place, Unredact will generate a list of candidate names. But we aren't just guessing here. We're cross-referencing the exact dimensions of this box against a database of known Epstein associates. We can uncover what was meant to stay hidden forever. I have a list of names, and now there's the smoking gun. A tiny pixel bleed right at the edge of the bar. That's the top of a capital S. Taking this into account, we've narrowed it down to just two names, Sarah Kellen and Steve Hansen, ranked in order by the strength of their bonds to Epstein himself. What you just saw was a live demo of a tool I'm working on called Unredact. Unredact is an attempt to use OCR, computer vision, and AI to help us uncover what the DOJ has hidden in these recent released Epstein files. We all know that it's not just victims' information that's being hidden from us, but the names of perpetrators and associates of Jeffrey Epstein. I'm releasing Unredact today as an open source project, so anyone interested can start using Unredact and maybe uncover a few names that the DOJ has hidden from us. I want to jump into more demos and show you all the capabilities of Unredact, but before that, I just need to give a huge thanks to the Epstein Sleuther. Her videos have inspired me to make Unredact in the first place, and anyone who's seen her videos already knows just how familiar I am with what she does. Also, R. Howard Stone put together this amazing network graph of all of the Epstein associates, and that graph feeds all of the data that Unredact uses to make these solves. So with that out of the way, let's jump into some more demos, and I'm excited to show you everything that Unredact can do. When we first boot up Unredact, we're met with this screen asking us to upload a PDF file. These PDF files can come directly from the Epstein library. I'm going to click on this one to get started. So when a document opens, we're going to run OCR analysis. Now, OCR is just a technology that's going to allow us to understand the text on a picture. So what my tool does is it will let you double click on a black bar. And what you saw happen in the background there was some OCR to figure out what the letters were, and then a computer vision algorithm to figure out what the exact font and typeface of the font in the document was. And then it tries to line it up perfectly for you. Now, you can see it didn't do it quite perfectly, so there are tools at the top here to make some micro adjustments to get the bars exactly where you need them to be. So let's go ahead and do that. And then there's also tools like this gap width here that allows you to set the gap of the redaction box itself. So now we have it so that this green text lines up perfectly with the original document, and we have the exact pixel dimensions of that hidden word. So now what we can do is we can go to the right here in this Analyze Redaction panel, and we just kind of put in the parameters that we're looking for. So we know we're looking for a name. We know the name's probably capitalized based on the other parts of the document. This man capitalized letters. Sometimes they don't. We can set a pixel tolerance for ourselves, let's say 0.5. And then we don't know exactly what this one starts with. That's not always going to be the case, as I'll show you in a moment. So I'm going to click Solve, and it's going to produce for me a list of names that exactly fit into that redaction box. My tool is going to rank those names based on how close that person was to Epstein. For instance, it really suggests Dowd as a potential candidate, and that's a tier 1 association with Epstein. So I can click on that, and we could see that Jim Dowd, this one refers to Jim Dowd, he traveled with Epstein. It also suggests Glenn. You may say, who's Glenn? You can click on this badge here. It'll say that's John Glenn or Glenn Dubin. So we'll just go with Glenn for now and click Accept. Now, I'm going to double click on this one, which is a bit smaller. And again, we're looking for a name that's capitalized. We don't know the first name. So we're going to hit Solve, and again, we get much fewer names this time. I'm going to go with Joe because I've looked at this document a little closely, and I highly suspect that it's Joe. Now, why did I say it's Joe? Well, that's because if you go all the way up to this redaction box here, we double click just as before. My algorithm is going to try to find the font face. In this case, it didn't do so well. So we have to correct it a little bit there. Line everything up perfectly. Now, in this one, there's a clue as to the name that's underneath this redaction box. You can see that there's some pixels bleeding out of this redaction box. We can actually use these pixels to help us determine who is hiding underneath these redaction boxes. So the question you have to ask yourself is like, what letter in Times New Roman at size 50 is going to produce pixels like that? Is it F? Well, no, not even close, right? Maybe P? Oh, it's a little closer. Y? No, actually it turns out to be J. So you see what I put a J there. It lines up absolutely perfect with those pixel artifacts. And in fact, J is the only letter in the English alphabet that's going to do that. So a lowercase j gets us there. So now that there's a J there, we have to go ahead and shrink our redaction box there. And then we can go to the right again, and we could say we're looking for a name that's lowercase this time because we know it's a lowercase j based on the pixel bleeds, and we know that it starts with a J. We're going to hit solve. But as you can see, Joe, just as before, Joe fits in this redaction box just as Joe fit down there. So sometimes it takes, looking around the entire document to get better ideas as to who are underneath these redaction boxes. Another tool that I'm working on is emails. Of course, everybody wants to know what these emails are. So we can do the same thing that we did with names with emails. I have to admit that this isn't quite as convincing as the names, but if I go over and get the exact pixels on this email box and put these carets in the right spot, I can go into email mode. I can say that I'm looking for a lowercase email. I can hit solve, and it's going to show me emails that we know Epstein emailed, and it's going to show me which ones fit underneath that that box there. So we'll just accept info at Coricon right now. So let's jump into another document with another mode that I support in Unredact. So we're going to look at this redaction box here. We're going to double click just as before. We're going to line up the text. Where this one missed a lot of text. That's okay. We'll put it in there. And we're going to line it up just as before. Now in this case here, we know, sorry, let me adjust this a little bit more. So in this case, we know that we're not looking for a name, right? We can tell that just by the sentence. One of complainant's ex-girlfriends blank told complainant Trump her, as did Epstein. So we know this isn't a name. We know that this is a word, and we know that it's a plural word. So knowing that, I'm going to use a dictionary I have in Unredact of 100,000 nouns, and I'm going to see which nouns fit underneath this redaction box. I'm going to click solve, and as you can see, it generated a list of 102 nouns that could possibly be underneath this redaction box. Now, 102 nouns is quite a bit, and not a lot of these make much sense. So this is where AI comes in. I can validate. So validate is going to allow me to invoke an LLM and tell it exactly what the sentence is. So in this left context, I'm saying to the left of the redaction box is this, and to the right is this. So told complainant Trump, I'm going to say abused her, as did Epstein. And then I'm going to hit run. So now the LLM is being sent a prompt that says, you are investigating a redacted document. To the left is this text, to the right is that text. Here are the suggested possible nouns that it could be, which ones make the most sense. And you can see after running that, we can see that half-sisters came back as the most likely word in the list of words that the solve generated. So there's a high chance that the word underneath this redaction here is the word half-sisters. So one of complainant's ex-girlfriend's half-sisters told complainant Trump abused her, as did Epstein. So that's the current state of my project, Unredact. This is a living project that I hope to make better every day. It's open source, so if you care to contribute, please do so. And if you're interested in uncovering the truth behind the Epstein files, I hope you find great value in this tool. Thank you so much for watching.